Uh, hey, this is Group 2, and this is Project 3, Sustainability and System Thinking. I'm Schweb, and Peace Engine. Our objective for this project is, and as peace engineers as a whole, is just we, as engineers, we process and analyze data in order to create products to serve to better serve the world and create a peaceful, more prosperous future. Our job is to use the data we collect to generate products which promote peace through both direct and indirect means. Uh, Big data must be harnessed and utilized to engineer a more peaceful tomorrow. And our main objective is to analyze tools and topics that will be of help to our overall goal for a more peaceful tomorrow. Uh, System thinking design. It's simply system thinking is an approach that designers use to analyze a problem in an appropriate context by looking beyond what the parent problem is and consider a system as a whole. The designers can expose the root cause and avoid merely treating the symptoms. They tackle a deeper problem and likely find effective solutions. And design thinking is pretty much the same, where they address the needs of the user by putting yourself in their shoes and tackling the problems by looking beyond it through multiple perspectives, and like create some visual designs to ease the concepts and put it into reality, constantly testing it through the process and exposing any hidden issues. These are some images of what system thinking is and how it relates to like design thinking. Like there are multiple types of system thinking, like causal loop diagrams, connected circles, iceberg module, and all that. And then system thinking, design thinking are basically this. Well, they're pretty similar. Where system thinking is like it's all in one big circle. Like it's kind of like uh, interconnected in like a weird web, sort of, but all in one circle. And then design thinking is just like everything has something in common. And then digital twin is a virtual representation of a physical, real world physical system or a project that serves as a indistinguishable digital counterpart of its practical purposes, such as system simulation, integration, testing, monitoring, and maintenance. An example of a digital twin would be like a use of a 3D modeling to create like a digital companion for like physical objects, and it can be like it can view the status of an actual physical object, which like provides a way to project physical objects into the digital world, like a 3D model of a car to check the status of the car through the digital mean rather than looking at it physically. And then here are some images here which basically like show what digital twin is. Like it saves money, it improves there's like some operational improvements, and it's a innovation catalyst. And like yeah, three elements of a digital twin is like the real world energy process, the data that connects the two, and the virtual representation. And yeah, it just allows the user to investigate solutions for product lifestyle extension, manufacturing and process improvements, and yeah, and product development and prototype testing. Uh, yeah,
Hello, I'm Nico. I'm going to talk about reuse, repurposing, and recycle. So this is basically a way for us to maximize our resources. It's exactly what it sounds like. So you want to reuse old technology, materials. If you can't reuse it, we can repurpose it. Old technology, materials, whatever, to make new technology. Um, it can function differently, and then recycle whatever you can't repurpose, and you can use it for other projects later. But this basically is just a way so we can maximize all our resources here on planet Earth, and we're not wasting a lot of things. Next slide. It's good because our world has a finite amount of resources. So, despite what many choose to believe, the Earth has a limited number of non sustainable resources such as fossil fuels, fresh water, and habitable land. If we as a society cannot build sustainable systems, the world will continue to decay. Building a sustainable system, such as transportation, energy, and production, does not mean building profitable systems. Next slide. Our world is decaying. So, despite our planet only having a finite amount of resources, large groups still choose to pollute and damage the environment. They do this because profit is their main goal, and they don't care what kind of damage they're creating for the environment for our planet. All they want is more money. Fossil fuels and water are very profitable for big companies to mine, and they are very cheap for consumers. On the right here, we can see a graph showing our energy reserves over the years, and it's predicted that in 2091, our energy reserves will be almost zero. Slide.
Cool. I'm Sunny, also on part or group 2, and here's how sustainability and systems thinking relates to SDG 2, which is zero hunger. Food insecurity must be solved through methods that don't further harm the environment. We can use engineering system design philosophies to design solutions that optimize output and help the most people while being environmentally friendly so that we don't pollute the environment extra through automation or anything like that. Through digital twins, we can simulate and approximate how much of an impact our solutions would have for communities before implementation. This allows us to prototype solutions without implementing them, thus saving cost, and also helps us to design the most optimal solution for each community on a case-by-case basis. And all products used and waste created must account for our finite resources and the environmental impact of the waste. We live on a planet with finite resources, and we can't just assume that we have infinite habitable land and infinite food to grow. We must always take those into account when designing for systems that address food insecurity. So how sustainability relates to SDG 10, which is inequality. When solving issues of inequality, we must be mindful that we don't further harm the planet. Of course, inequality is a horrible thing that happens in all of our societies. However, we can't just address that without also considering the impact that the solutions may have on the environment and the planet as a whole. Systems thinking cannot be applied to inequality since that detracts from the human aspect and reinforces dehumanization of marginalized groups. Nobody is a statistic, and through systems thinking, big data, captology, and all of those data collection and analysis tools, you're essentially rendering marginalized groups and peoples as a simple statistic, which further hurts them through inequality by dehumanizing them. Addressing inequality must be done through environmentally friendly means as well, and we can't take our resources for granted. And finally, we must shift the focus away from capital seeking and towards goals which emphasize equity and our environment. And finally, here's how sustainability relates to SDG 16, which is strong institutions. Environmental agencies such as the EPA must be strengthened in order to promote environmental protection and sustainability. Right now, there are a bunch of companies like Nestle, Coca-Cola, and a couple of other ones right now that are polluting our rivers, streams, and lakes, and just in general harming the environment, at least in the US alone right now. And that's all because governmental agencies like the EPA don't have enough of a say and enough authority over exactly how we should be protecting our environment. And also, from studies, corruption is more likely to harm the environment, and thus reducing corruption also reduces its harm to our planet. One example right now would be what's happening in Brazil. The Brazilian government is incredibly corrupt, And because of that, it is able to ignore all of the environmental restrictions and regulations that the UN has set up. And they've been cutting down and burning large parts of the Amazon rainforest. And that's just due to their corruption. And here are a couple of our sources where we got all of the data for this presentation. Thank you.
Yeah, that was our project 3. Thanks for watching.